Hello everyone. In this lesson we're going to demonstrate how to configure a generic routing encapsulation, or otherwise known as GRE tunnel, with the aim to create a virtual point-to-point connection between router 1 and router 3 of our topology. This in turn will allow the 10.0.0.10 host to be able to talk to the PC of the 10.0.1.0/24 network. So the first thing we're going to do is to configure the underlay network, which is essentially the necessary IP routing in order for router 1 to be aware of the public interface of router 3 and vice versa, before we get to configure the overlay network associated with the GRE tunnel that is going to be 172.16.0.0/30 network. So without further ado, I will jump into router 1, into config mode, and I will put in place a static route pointing to the network of router 3, the public network of router 3 that is, which is 192.168.23.0 with its subnet mask of 255.255.255.252. And the next hop router for this route will be the 192.168.12.2 IP address of router 2. Do wrmem to save the changes, close the window, and we shall do the reverse on router 3. Into configuration mode, IP route 192.168.12.0, which is the public network of router 1, with its subnet mask of 255.255.255.252. And as the next hop router, we will specify the IP address, one of the IP addresses of router 2, the one that's facing router 3, which is 192.168.23.1. Do wrmem to commit the changes to memory and close the window. Having done that, we shall now proceed to configuring the overlay network associated with the GRE tunnel. So back into router 1, into configuration mode, and we shall configure a tunnel interface of 0. We shall give it an IP address of 172.16.0.1, subnet mask 255.255.255.252. Next, we shall specify as its tunnel source the serial interface of router 1, which is 0/1/0, and the destination endpoint of the tunnel is the public IP address of router 3, which is 192.168.23.2. Do wrmem to save the changes, and we will do the reverse on router 3. So into the configuration mode of router 3, interface tunnel 0, IP address 172.16.0.2, 255.255.255.252 is a subnet mask. Tunnel source, it's a serial interface, and it is actually, I don't think I need to specify the IP address for the source. I just need to specify the interface, which is 0/1/0, and then for the destination endpoint of the tunnel, we will specify the IP address of router 1, the public IP address of router 1 that is, which is 192.168.12.1. Do wrmem to commit the changes to memory, exit out of there, And let's see if our PC from the 10.0.0.0/24 network is now going to be able to communicate to the PC of the 10.0.1.0/24 network. So I will open up a command prompt. Just to confirm the IP address of the PC, I run ipconfig, and let's run a ping against the IP address of the remote PC, which is 10.0.1.10. We can see that the ICMP requests are not successful. They all result in the request timeout error. And the reason for that is the fact that we haven't configured the necessary static routes that point to the appropriate tunnel endpoints. And so if I go back into router 1, I will exit out of the config-if mode, and into config mode I will put in place a new static route that points to the remote network relative to router 1, which is 10.0.1.0 with its subnet mask of 255.255.255.0. And as the next hop router, I am going to specify the IP address of router 3 that is associated with the GRE tunnel, which is 172.16.0.2. Do wrmem to save the changes, exit out of there, and I will do the reverse on router 3. So into config mode, IP route, followed by the remote network relative to router 3, which is 10.0.0.0, subnet mask 255.255.255.0. And what do you think that the next hop router is going to be? Correct. The tunnel interface, or the IP address associated with the tunnel interface of router 1, which is 172.16.0.1, thereby forcing the traffic to go through the GRE tunnel. Do wrmem to save the changes, close the window, fast forward the time to make sure that all of our changes have taken effect, and let us go back to the command prompt of our PC and try pinging the remote host once more. So we can see that it's thinking about it. The first request results in a request timed out error, but then the subsequent 3 requests are successful. If I do the reverse, and ping 10.0.0.10, we can see that I'm able to do that also. And interestingly, if you want to verify that the traffic is being routed through the GRE tunnel that we established earlier, we can run a tracert command instead against the same host, 10.0.0.10. And you can see that the second hop router is the IP address associated with the tunnel interface of router 1. Similarly, if I do the reverse and replace the ping with the tracert command, we can see that the ICMP requests initiated from the PC in the 10.0.0.0/24 network towards its remote counterpart are going through the IP address associated with the tunnel interface of router 3. I hope this makes sense, and I hope that you got some value out of this lesson. Thank you very much for watching.